My name is Ashray Agarwal, and currently I'm working as a senior software engineer at Uber. So, today we are going to talk about a very important concept in system design, which is load balancers. So, let's start with a scenario. So, let's say we are building an application and we are in college and we want to build something like storing photos, and I am just making it as a college project and hosting it on my own computer. And it's currently only shared with all my friends in the college. So you can think of it like my friends are using an application. So now this is the application that I have built, and and this is my computer, and I'll be using this computer to store all the photos. So what happens? The request goes from my app to the internet, and then from the internet it comes to my computer. And in my computer, what I'm doing, I am storing the photos for my friends, and they can also get the photos whenever they want to. So now they don't have to carry any pen drive or any other device to get the photos. They can just log in from any device and get the photos, and they can just log in from any device and store the photos. So what goes behind the scenes? So when the request comes to the internet, right? So it first goes to the DNS servers, right? And from the DNS servers it comes to my computer. And let's say my host is, let's say for example, 1.1.1.1, and everything was working fine. And all of a sudden I see that like my application is getting very popular and it is getting too much traffic. So will my system be able to handle, so let's say 1,000 requests? Yes, we can. What about 100,000 requests? No, now things will start getting messy, right? And we won't be able to handle 100,000 requests because my system has like limited CPU, limited storage. So these things are limited, right? What can I do? I can add more storage to my system. I can add more compute power to my system. And let's say I was still able to serve 100,000 requests. But what about 1 million requests? Now there is definitely a threshold, right? Like I cannot go beyond a certain point. So now what can I do? I can then think of adding more servers for my application. So now what will happen, I'll say, okay, I bought another computer. So this is computer 1 and this is computer 2. The request is coming from the application to the internet, and now the DNS servers needs to figure out where do it wants to send the traffic, whether it wants to send the traffic to computer 1 or computer 2. How do we do that? Like it's very difficult, right? Like we cannot say that always send the traffic to computer 1 because then the problem still remains the same. So what can we do? We can introduce something like a load balancer over here. This is a load balancer. Now when the DNS tries to resolve the IP address, it would always resolve the IP address of the load balancer. It will always say that the IP address is of the load balancer. And then load balancer can internally decide whether to send this request to computer 1 or to computer 2. Right? So what is load balancer doing here? So load balancer is serving a lot of and giving a lot of capabilities for us, right? The first thing it does is availability. So now what is actually happening? So what it is happening, like tomorrow if my traffic again increases, I can add more instances of computers to behind the load balancer, and the load balancer will try to send the traffic to all the computers based on some algorithm. We'll see what the algorithm is. Okay, so now what are the operations that the load balancer does? Load balancer does the health checks. So it is checking whether my computer one is healthy enough to take those requests. If it's not healthy, it would mark it as unhealthy and then stop sending the traffic to computer one. And it can also spawn up new servers. So let's say it sees that currently all the computers are all the servers are like kind of full and they cannot like take the capacity or the load. It can also try to spin up new set of servers and like computer 3 and then start sending the traffic to those servers. So it ensures or provides like availability for your servers, right? It also provides some kind of security. Why? Because like no one is directly calling the servers, which is your computer 1, computer 2 or computer 3. Everyone is directly interacting with the load balancer, and in turn the load balancer is taking the traffic to all the different computers. So no one is actually aware of what the IP address of the servers behind the load balancers are. So the IP is hidden, right? So no one cannot directly connect with your servers. And it also helps in traffic distribution. Now there could be various algorithms, so depending on what algorithm we choose, depending on the algo, we can determine what servers this particular request should be routed to. Okay, now we'll see like what are the types of load balancers, right? The first one is the network load balancer. So in the network load balancer basically works and is on the network layer of the OSI layer, and it works only on the IP and the port. So only the IP and the port is visible. So the request is coming from some source, right? So only the IP and the port is visible, and it cannot look at what the actual packet is. Like the network load balancer doesn't have the capability to look into what the actual packet is. It can only look into the IP port and some headers and then decide where to route the request to, right? Now the second type of load balancer is the L7 load balancer or the application load balancer. So what this application load balancer does, so application load balancer can read the packet or the payload. So whatever request you send, it can read that. It can read the URLs. It can read a lot of things, right? So for example, this is your load balancer, and you have a lot of microservices, right? Like for example, there is a user profile service, there is a photos service. Let's say there are two services, right? So let's say it can say that, okay, if you are trying to search for like /users/me, so let's say if you want to open your profile, then it would redirect the traffic for all these endpoints to the user service, while anything which is like /photos, maybe /star, goes to the photo service. So based on what the URL is for the request, it can route the traffic to the servers which actually host those endpoints. Okay, so these are the high level, like the two forms of load balancers. Now we can discuss on the algorithm. So how will the load balancer distribute the load among the different servers that are sitting behind, right? So there could be any, like we could come up with any algorithm, but like some of the most popular or the most commonly used algorithms. So the first one is the round robin. So what it does, so let's say this is your load balancer, and then there are three servers, S1, S2, S3. Servers are nothing but computers, right? So it would say the first request would go to server 1, the second request would go to server 2, the third request would go to server 3, then the fourth request would go to server 1. So it's like round robin, so all the servers will get one by one a chance to serve each request. The second form is the weighted round robin. So what it will do, so let's say that there is a traffic that is coming in, right, and we have defined a distribution pattern, like 10% of the request should come to server 1, 40% should come to server 2, and then server 3 can have support 50% of the request. So what it would do, it would be like, let's say if there are 100 requests that are coming in, so it would ensure that 10 requests go to server 1, 40 requests go to server 2, and 50 requests go to server 3, right? So the first request comes, it goes to server 1, then the second request comes, it goes to server 2, the third request comes, it goes to server 3, the fourth request comes, it would say that okay, currently like the 10% quota has been exhausted for server 1, so let me send the fourth request to server 2. Then it would do around, I would say, fifth request go to server 3. So it would try to distribute the load based on the percentage that you have defined that each computer can take. Why is it so? Because not all hardwares are configured the same way, right? So that's why it happens that, like, you can say that okay, this is a very small machine, so it can only support 10% of the load or something like that. You can come up with some factor. The third type is the least connection based. So it's like, so let's say whenever you are sending a request, right? So let's say if there would be multiple types of requests, like uploading a photo would be an expensive operation, while just reading the photo might not be an expensive operation. But in the first two algorithms, there was no check on what are the expensive operations, what are the less expensive operations, and already how many requests a particular server is processing. Nothing was taken into account. It was just doing random distribution based on the round robin manner. Now we do something like this. So let's say if a particular server, this is the load balancer, and there are, let's say, 3 servers, S1, S2 and S3. Now the first server is taking a lot of time to respond to the request, and it already is processing a lot of requests. So let's say in the current configuration we have something like this. The first server is already serving 2 requests, the second server is already serving 2 requests, the third server is already serving just 1 request. So the next request which comes, it would by default go to the third server, because it would say that this has the least number of connections, so I would route my traffic to the third server. Okay, so there are a lot of algorithms, and these are like the most commonly used algorithms that we have, right, for load balancers. Now we would think of a case that okay, so load balancer is also a single point of failure, right, over here, right? Like, what if the load balancer goes down? Then like I'll not be able to serve any traffic. How does that scale, right? So whenever we talk about load balancers, they also work in kind of, there are cluster of load balancers. So it's like, you can think of it like it works in an active passive mode. So it's not that there is just one load balancer. There is like a load balancer 1 which is in active mode, and then we can have a load balancer 2 which is in a passive mode. And then when the active load balancer goes down, the passive load balancer can take the position. But there is one problem. Now the user is sending the request, right? And your load balancer 1 would have, let's say, IP1, your load balancer 2 would have IP2. Okay, now what would happen, right? When the load balancer 1 dies, then the DNS would still say, the DNS server would still say that I want, like, this is the IP address, because see, the DNS server propagation of, let's say, whenever you want to change the IP addresses, the propagation takes a lot of time, right? Like, because there are a lot of levels of caching that is involved in the picture, inside the DNS server. Okay, so now if you want to say that or route all the requests to IP2, it would be a very tricky task. So there is a concept of a static IP, or you can say, so what we do in static IP, you can think like, if this is the active load balancer, this is the passive load balancer, right? If the active load balancer goes down, okay, the IP address would still remain the same, and the passive load balancer's IP would now be remapped basically to the, again, the static IP. So IP address is not changing, so the request would start flowing into the passive load balancer and everything else would work just fine, right? Now there are two different ways of, I would say, so this is one way of scaling load balancers that you run in active passive mode, but there are another ways of doing so, right? Like, how do I scale load balancers? Okay, one way we have already discussed, right? So what we can do is we can use the DNS as well, because DNS, what DNS is doing, DNS is saying that, hey, if this is the IP address, I'll forward the request here. If this is the IP address, I'll forward the request here, right? Because it knows that what is a machine, right? So what if we say something like this, like we start using a DNS round robin? So I'm talking about scaling load balancers. Like, for example, if you see like Google, Amazon, if you just try to see like the IP address for google.com, you'll not see just one IP address. You'll see a list of IP addresses, IP1, IP2, IP3, right? So since Google, Amazon, they're supporting a lot of traffic, so what they do is they have a multiple IP addresses, and each of the IP addresses is nothing but an IP address for some load balancer. So we can configure multiple IP addresses for our website or any domain, and then what we can say is that, okay, so now DNS can pick any IP address and then start sending the traffic over there. So let's say so you can think of it like, let's say if there were 100 requests and that you had 4 IP addresses, IP1, 2, 3 and 4. So you can think like the load balancers are there, right? So the load balancer 1, 2, 3, 4. So there are 4 load balancers. So now each load balancer from the DNS server only, it would start receiving only 25 requests. Approximately 25 requests, because it also has like some kind of a round robin over here. So approximately 25 requests. So automatically you're able to scale your load balancers as well, right? Now there is another form of load balancing that usually is very common, which is like, from the scaling perspective, is the geolocation based. Okay, so you can think something like this. Let's say there are 2 users. User 1 is in North America and user 2 is in India, right? And both are trying to access the same site, that is, for example, google.com. Okay. So now what it would do is, say there would be 2 set of load balancers here. So one is the India servers and one is the US servers. Let's call it 1.1.1.1, 1.1.1.2. Okay, so now if you're trying to, let's say, get a photo or something, so if the request is coming from US, then all the traffic would be redirected to this load balancer. So all this traffic is going. here, and if the request is coming from India, all the traffic goes here. So these are the different ways in which you can scale your load balancer. And we also learned about like why load balancer is required, what are the different algorithms, how do we scale load balancers, a number of things, right? And again, like when we start building applications, we'll see the use or the importance of load balancers, and it's heavily used in almost all the companies, right? Like because everyone wants to be available all the times, and they want to protect their actual host that is behind the load balancers, so everyone is using it. I hope you got an understanding of how load balancer works. Yeah, so keep learning, and yeah, thank you.